Hey, welcome to another lesson. This is 15.2, Isosceles and Equilateral Triangles. Your objective for today is to learn about special relationships that the angles and the sides have in an isosceles and an equilateral triangle. Okay, so here we go. Before we go ahead and we talk about the different relationships that they do have, we have to first talk about a triangle. Okay, we're gonna just do basic labeling of the sides and the angles. So this side here that's on the ground, basically, right? You guys can imagine, is called the base. Okay, base side. Here, these angles then, here and here, are called the base angles. Easy enough, right? The base and the base angles. This angle here is called the vertex angle. And these two sides here and here are called the legs. Okay, the legs of the triangle. All right. So that's the basic layout of everything. Okay. And what an isosceles triangle is, we all kind of know what it is by now, right? So if I have an isosceles triangle here, okay, and I label that this side is congruent to this side, right? They're equal to each other. Okay, that's what an isosceles triangle is. So an isosceles triangle it's with an S, not an X. Okay, triangle is a triangle with two congruent sides. Okay, now here's what's cool about it. If an isosceles triangle is a triangle with two congruent sides, the sides opposite these angles are also congruent. So the angle opposite those sides, are also congruent. So if I'm talking about this side here, I'm going to label it just so that we can talk about it, A, B, and C. If I am talking about angle A or side AB being congruent, right? AB is congruent to BC. Okay. Then I know that side or angle A is congruent to angle C. Okay, the sides opposite those angles are also congruent. So that angle, because it's opposite that side, and this angle, because it's opposite that side. And remember the tick marks. Okay, if they have the same little tick marks, then that means that they are equal. Okay, so an isosceles triangle is a triangle with two congruent sides. Therefore, we have two congruent angles as well. All right, so that's what an isosceles triangle is. And what's up next is, look, I just drew that, right? I just drew it on the previous picture, right? So if I know the black, that these two sides are congruent, I automatically know that these two angles are congruent, right? So if two sides of a triangle are congruent, then the two angles opposite the sides are congruent, okay? And they are color coordinated. If I know the black, then I know the red, and vice versa. If I know the red, right, if you're given a triangle, let me draw a triangle here. And if I said, hey, look, this angle and this angle are congruent to each other, right? Then I know, then the two sides opposite the angles are congruent. Then that means I know that as well. Okay, so that they're going to be congruent as well. All right, easy enough. Flipping over to what an equilateral triangle is now. Equilateral triangle, it means that all the sides are congruent. Okay, it means the black. Okay, so I drew it out already, right? And I kind of gave you guys what's coming up next. If the sides are all congruent to each other, right? Then taking the isosceles triangle definition, if these two sides are congruent to each other, then these two angles opposite those sides are congruent to each other, right? So if these two sides are congruent to each other, then the angles opposite those sides are congruent to each other. So all three angles are also congruent, okay? If all three angles are congruent, if all three angles are congruent, then it's an equal angular triangle. Okay? If all three sides are congruent, then it is an equal angular triangle. And again, if all three sides are congruent, then it's an equal lateral triangle. All right? So if all three sides are congruent, all three angles are congruent. If a triangle is an equilateral triangle, then it is also an equal angular triangle. If the triangle is equal angular, then the triangle is equilateral. Okay? We can take it a step further and say, hey, look, if we have an equilateral triangle, then we have an equal angular triangle. And if the triangle, the sum of the interior angles are equal to 180, then each angle is actually, measure of an angle is actually 60 degrees, right? Or 180 divided by 3, which is 60 degrees. So that's 60, and this is also 60. All right? Okay. So we got that. We got what isosceles triangles are. We got what equilateral triangles are, or equal angular triangles. Okay, let's do some examples. All right. So example number 1 is this. So we have this isosceles triangle, right? Now, if these two sides are congruent, this the north and the south side are congruent, then I know for a fact that the angles opposite those sides are congruent, right? So I know that. I know what's in red, right? So if this is 3x plus 3, then this angle also must be 3x plus 3, right? So if that's 3x plus 3, that's 3x plus 3, and we're given that this angle here is 5x minus 2, all I got to do is add them together and make them equal to 180. So 5x minus 2 plus 3x plus 3 plus 3x plus 3 equals 180. Okay, and I'm going to do some math. 5 plus 3 plus 3, that's 11. 11x minus 2 plus 3, that's positive 1. Positive 3, 1 plus 3, that's 4, equals 180. Subtract 4 on both sides. You're left with 11x equals 176. Okay, 176. $176 divided by 11. So x is going to equal 16. That's perfect timing for my Apple Watch, if you guys heard that ding. Okay, so that's the first example. All right. My next example is this. Okay, so we have 3/10 y plus 9, and we have this side as 4/5 y minus 1. So, and I'm given that these angles are congruent to each other, right? If it's equal angular, I know two things, that each angle is 60, and all three sides are also congruent, right? Each angle is 60 because they're equal to each other, right? And the interior angles are equal to 180. And if all three sides are equal, or if all three angles are equal, then all three sides are equal. So what is the length of each side? Well, if they're equal to each other, then 3/10y plus 9 equals 4/5y minus 1, right? I do not want to deal with fractions, okay? So my thing is, if I see a fraction, I'm just going to get rid of it. I'm not going to get rid of it, or I'm going to get rid of it by multiplying by its lowest common denominator. So between a 10 and a 5, the LCD is 10, right? Because 10 goes into 10 and 5 goes into 10. So I'm going to be multiplying everything by 10. So now if I distribute the 10 out to this will just be 3y. 10 times 9, that's plus 9d, equals 10 goes into 4/5 y. That is actually 8y, because the 5 and the 10 cancel out, and you're left with 2 on the top. So 4 times 2 is 8, minus 10 times -1 is -10, right? And then we're going to proceed by just gathering the like terms. I could add 10 to both sides. Simultaneously, I'm going to subtract 3y on both sides. Now I am left with these two guys being canceled out and these two guys being canceled out. So then that's 100 equals 5y. And then I'm going to divide by 5, divide by 5. So my y value is equal to 100 divided by 5. That is 20. Okay, so y is 20, and make sure that you reread the question. Okay, what is the length of each side? Well, if y is 20, and these guys are my sides, I'm just going to multiply. I'm going to go with 4/5. 4/5 times 20 minus 1, right? I just plugged in y equals 20 into here. Okay, so I got that. 20 goes, or 5 goes into 20 4 times. So 4 times 4 is 16, minus 1, that's 15. Okay, so each side length equals 15. All right, and that's the lesson for 15.2 on isosceles triangles and equilateral triangles.